Here we go. Today, looking at combinations versus permutations. Number one thing, do me a favor now. Let's go back. I had to fill out that survey about how present you've been. Let's be present now, please. Okay? Be present. Let's focus. Okay? Like I said, the lesson's not very long, so let's make sure we're understanding the parts that we do have. So pause if you're working on the homework. Pause for 10 minutes or 5 minutes or whatever this lesson is, and then come back to that in a little bit. Okay? So here's the difference between a permutation that we did yesterday and a combination like today. I'm going to actually use, we didn't go over it, but number 25 where they talked about dice and how many different ways could you roll two dice. Okay, different combinations could you come up with. So the difference between a permutation and a combination. A permutation, the order of the dice matters. So if you roll two dice and the first one is a 1 and the second one's a 6, versus the first one is a 6 and the second one is a 1, those are two different permutations because the order matters, which one came up first. That's only one combination of numbers because it's a 1 and a 6 regardless of the order. Okay? That's the difference between what a permutation where the order does matter versus a combination that I don't care if it was a 1 and a 6 or a 6 and a 1, it was those two numbers regardless. Okay? So that's kind of where we're headed. What this should look familiar. In general, it's the exact same thing that we looked at yesterday with permutations and that formula. The only difference here is, if you notice, yesterday when we did NPR, okay, permutations, it was n factorial divided by n minus r factorial. Today we've got an r factorial in the denominator as well. Okay, so we're dividing out a little bit more. The reason for that is what I just talked about. Because order doesn't matter, there's going to be less combinations. That's what that r factorial does, is it gets rid of like 1 and 6 versus 6 and 1. Well, who cares? It's the two numbers. That's what's going on with that. Otherwise, pretty much the same formula, same idea. Okay? So let me give you an example. Here's the idea of a combination. You got 51 contestants in a Miss America pageant. You need 10 finalists. Okay? And this could be anything. Doesn't really matter what the scenario is. You need a top 10. Okay? People are getting to the finals. First question. Let's go real life for a second. Why is there 51 on here?
51 states/provinces.
Okay. It's the 50 states plus DC. Yeah, that's why there's 51. Okay, so that's where the 51 is coming from. Here's the question I have for you. As we try to figure out all the different ways we could get a top 10, does it matter whether you're the first person in the top 10 or the last person in the top 10? No, it just matters if you're in the top 10, right? It matters if you make the finals. That's it. That's why this is a combination and not a permutation. Then it will become a permutation. Then we'll start to say, all right, now we need a first place, second place, third place. Then order will matter from there. But to get this, it's just how many different ways can we get a top 10. So what this would be 51 combinations, or choose 10 at a time. Okay? You got 51 contestants and you're trying to choose a top 10. Even though C stands for combination, you're going to hear me say choose a lot. Okay? Just because it makes more sense. 51, choose 10. That's what this says. Okay? And therefore, if we write this out according to our formula like we had before, that means we have 51 factorial over r factorial. That's how many you're trying to choose. Okay, so that's 10 factorial times the difference between the two, which in this case would be 41 factorial. Okay. And so now you could type this into the calculator one of two ways. Remember, if you're going to type it in with the factorials, don't forget to put parentheses in the denominator, so you're telling the calculator, divide by that whole quantity, not just the 10, okay, not just the 10 factorial. Or you can type it in. We saw yesterday where you found the permutations and combinations in the calculator. Matter of fact, I'm going to go to that. If I'm trying to type that in directly and not have to even worry about the factorials, again, depending on the calculator, some calculators, if they're newer calculators, you're going to go straight to the combinations, then just put the numbers in. I've got an older calculator, which means I need to type in the first number. I need to type the 51 in. Okay, so if I type that in, Then remember we go into math, and you arrow over to probability, the probability menu.
That is definitely not right.
But now, instead of permutations, now we're choosing number 3, combinations. Okay? And then we type in the value of R, which in this case we're choosing a top 10. You hit enter and it comes up with this huge number. What does E10 mean, by the way, at the end? That's just scientific notation is what that is. E10 is times 10 to the 10th, which means what do I do in order to get this actual answer? Not 10 zeros. Move the decimal 10 to the right. Okay, remember scientific notation, if it's times 10 to the 10th, if it's a positive power, that means we got to move to the right. So if I take that decimal and move it 10 places to the right, we end up with a final answer here. Oops, that's not the right button. Hang on. Where'd my sheet go? We end up with a final answer of 12,777,711,870. 870 is, I think, what I have. Yeah, is that right? Oh, did I say 770? Sorry. 870, sorry.
That's how many different things you can get?
That's how many different ways you could get a top 10 out of 50, out of the 51 candidates in this.
That seems like way too much.
Okay. Well, if you think about it, though, if you got 51, and let's say you just pick 10. If you just change one of those, if you change out one, then you change out the one again to a different person, then you change out the one again to a different person.
Yeah, that makes sense.
That's why there's so many. Every single one of those is a different top 10. The order of the top 10 still doesn't matter. That's why it's not a permutation. That's why it's a combination. But anytime a combination is basically, you've got this many options and I'm choosing however many. That's what a combination is. Okay? In this case, I was choosing a top 10. Let me give you another example. Let's go to the next one. Pizza example. So you've got 10 different pizza toppings to choose from. We're going to try to figure out how many different pizzas could we come up with if you're going to choose 3 toppings. First question. Does it matter which order the toppings are put on the pizza?
No.
Which is why this is not a permutation. If the order mattered, then we would be doing permutations instead of combinations. All that matters is which 3 are on there. Okay? So, again, when we're trying to make a choice, what we are doing is we've got 10 options, and we are choosing 3 of them. Okay? Whatever the 3 are. Doesn't matter which 3. We've got 10 options, and we're choosing 3. That's what that represents. If you write this out again, and this is really the only work that I want you to show today, that you need to show, again, is where the answer is coming from. So again, this would be 10 factorial over 3 factorial times the difference between the 2, which is 7 factorial. Okay. And then from there, type it into your calculator one way or the other. I don't care which way you type it in. Okay. Ultimately, what do you get for an answer? How many different pizzas can we come up with? 120. You get 120 different pizzas that you could come up if you have 10 different toppings that you could put on there. Okay. Again, combination, because it doesn't matter the order that you put the toppings on. It just matters that you've got 3. All right, last example. This one's a little bit different. Same idea, but a little bit different option here. So now if I'm going to choose up to 10 toppings, keywords here, up to. So we don't have a specific, like here it was 10, choose 3. I don't have a specific number, so what do you think? How do you think we go about this? There's a couple ways. You could, the longer way, you could say 10, choose 0. Could I have 0 toppings, by the way? Is that a thing? Yeah, cheese pizza, right? So we could go 10, choose 0, plus, could I have only 1 topping? Yep, we could have 10, choose 1. And then you could go plus 10, choose 2. all the way up to 10, choose 10. Okay. You got 10 toppings, you could choose all 10. You could put them all on there. You could do that. That's the concept. Not going to, because we can get there a whole lot quicker. Okay? Anytime you see this up to, those two keywords where you don't have a specific number that you're choosing, I call these yes-no problems. Here's why. Just like that problem 26 in the assignment where you're flipping the coin, and it was heads or tails, heads or tails, heads or tails. Anytime you have up to 10 toppings, we say, all right, first topping, yes or no? Second topping, yes or no? Third topping, yes or no? Which means this is really just 2 to the 10th power. You're asking yourself yes or no 10 times because you've got 10 toppings. It's just like the flipping the coin problem, number 26 from the assignment. And therefore, you end up with 1,024 different ways you could end up with a pizza. So again, anytime you see that up to something, or when you have options but you don't know the specific number that you're choosing, think of it as a yes-no problem, a 2 to a power. Okay? The 2 coming from the yes or the no, 2 options. Yes, it's going to be on there, or no, it's not. Okay? You would have got the same answer, by the way, if you did it this way. It's just a whole lot longer to get there than it is to just say, oh, that's just a 2 to the 10th kind of problem. Okay? Questions at all? Biggest thing I want you to understand, because we're going to use combinations next week when we go back more algebra-based. But in order for you to understand that's why we took yesterday and today to kind of look at permutations and combinations, so you had at least some background information to understand what you were looking at. What I want you to do today then, with the rest of the time, you have the worksheet, the 9-1 worksheet already. The problems on the worksheet, I put a box around those problems. Okay? So the circled ones were the ones from yesterday. The ones that have the boxes around them, which are these, are the ones for today. Just show me the setup, okay, of those problems. And a quick heads up too, by the way, I almost forgot to mention this in the other class. The 19 through 22, all they're asking you is, here's a problem, is this a permutation or a combination? That's all they're asking, okay? There is no work to show. It's just determine whether order matters or order doesn't matter, okay? So and obviously the answers are already there, so make sure you understand the answers is really the idea. Understand why it's a permutation versus a combination, okay? You got the rest of the time to work. That way, if you've got questions, you can ask. If you're still working on older assignments and you need some help on any of those, I will help you with that as well. Okay, let's go to work.